Oh, so this time we're doing a SQL Server video. There's a novelty. Pure SQL Server. Strange, I know. But yeah, the reason I'm doing this is actually driven out of annoyance. So hopefully I won't get too ranty in this video, but we'll all see how it turns out. Basically, this came from a client I was working with who got an email response from a vendor. And it just kind of dug up all of the arguments I've had over years with people about architecture in SQL Server. And so I thought, instead of venting at the vendor, I would vent out in a video and see what happens. So the issue, everyone will have come across it at some point. It's the good old primary key being the clustered index on a table. Now, the whole thing is, I've done interview after interview. I've had people interview me, and a lot of the times people will say, okay, you've got an auto incrementing column on your table. It's a not null. It's your primary key. What index should you put on it? And as standard default answer, people just go, oh, clustered index has to be. And it's incredibly rare that you actually get someone who steps back, thinks, and gives effectively the right answer. The right answer being, it depends, because how is your table being used? What's the access pattern on that table? Without knowing that, you have no idea where the clustered index goes. Okay? Now, the reason I got annoyed with the vendor is basically because their application is running slowly. The database has no indexes apart from clustered primary key indexes. That is it. Nothing else. That's all that's on their tables. And when we kind of questioned it and we sent them an email just kind of going, oh, you know, do you mind if we kind of re-index your database for you, add some indexes, etc.? Is this going to be a problem? And they basically wrote back saying, oh, you know, don't worry about it. You know, we know it's not necessarily best practice to have primary keys and clusters as the same thing. But, you know, it doesn't really make a difference to us. It's like, well, how can it not make a difference? And their argument was, oh, the way we access SQL, it doesn't make any difference, so we've just gone with it. And it's like, no. The clustered index, your indexing strategy, your architecture as a whole kind of defines the performance of your database. So I made a demo. So what I've done is built a phonebook. Now, don't get me wrong here, before I do kind of go off on the phonebook one, I will clarify, it can be perfectly correct to have your clustered index as your primary key. Okay, depending on how the table works, perfectly plausible. I'll cover all of that later, but for the moment I just want to kind of go along with why it's important to get it right, what it can actually mean to index things correctly, and why it's generally completely incorrect to say it doesn't really make a difference to our access patterns. Unless you are pulling every record from every table every time you touch the table, it makes a difference. So anyway, phonebook. So what I've done is I've just created a dummy phonebook table. So what we've got is we've got a title, first name, last name, phone number, address. Nice and basic, but what I've done, you can see here, I've used a big int for the person ID, not necessary, I'm just bloating the column. Basically, in the real world, you're going to be seeing big fat tables, huge numbers of rows. I can't really mimic that without taking down my test environment. So I've basically just made a table that's a lot fatter and bigger than it should be, just to indicate fat table, this is how it works, without actually having to chunk all the data in. So hence why everything's an nchar, because a char is obviously a fixed width column. These don't need to be not nulls. I was just typing away and out of habit just started typing not null. But they're chars, so they're fixed width, but they're nchars, which obviously doubles the size taken up. I've put a few defaults in. So basically I've just made a simple phonebook table. Then what I've done is I actually have in my main demo database my food and stuff, so kind of my fake restaurant, my fake supermarket database. I've got a table with around 30,000 customers in it, all fake names, but they are just names. So what I've kind of done is just taken distinct last names, distinct first names, and then I've just cross-joined them together to just make a big fat list of names. Because I only have names, That's why I've added defaults to all the addresses, just to put something in there. It's not necessarily their nchars anyway, but and then for the phone number, I didn't want to generate thousands upon thousands of phone numbers, so I basically just used the last 12 digits of a GUID. So it may not be completely unique because it's just the last 12 digits, but chances are it's going to be unique. But it's kind of irrelevant for this anyway. I'm not doing this on a uniqueness thing. I just wanted something that looked a bit kind of phone booky. And when I'd run that, what I ended up with is a table that has, oh, I haven't actually run it. Let's rerun this. It's a table that has roughly, I think it's about 260,000 records in it once it's done. So I'll run this, and there we go, 256,000 records. So we get kind of a relatively hefty phone book table. Now, that's currently empty. If I do set statistics IO1, so we can actually see the reads that we're doing against our database. For anyone that doesn't know, I am not going into details. I mean, we do training courses on this kind of thing, but basically everything is stored in 8K chunks in a table. Again, not going into details. And so effectively one read is reading one 8K chunk. So it's effectively how many times you've had to hit the disk looking for these 8K chunks of data. So we're going to look at kind of just read totals. All you really need to use the reads for is just a guide as to effectively how hard it's hitting your disk, worst case scenario, or your RAM, depending on where the data currently resides. But obviously the less you're hitting things, the less resources you're using, the less CPU you're using, the less memory you're taking up by holding data pages in it, etc, etc. So all we really need to know is smaller reads, much better performance. Higher reads, worse. Simple as. So we're going to go with that for the moment. So if I just do a select star from Phonebook, we can run this. Now it will return 250,000 rows. It's going to be relatively slow because it's streaming it to the screen, but we'll stop it doing that when we start doing Azure queries. So you can see that because I've padded all of my data, I mean, it looks small, but because I've padded all of these cells to make them really quite big, you can see it's 64,000 reads. So we basically hit the disk 64,000 times. That's pretty heavy. Okay. Now, what we've got is we've got an identity column because I set this as an identity column. So we can go down the good old route of alter table, Phonebook, add constraint. And what we're going to do is we're going to add the constraint, and we are going to add the primary key, Phonebook primary key clustered on person ID. Okay, so we now have the typical primary key clustered. I mean, obviously, if you go back here while this is creating, if I just change this to be the lazy approach and just put primary key, by default that will create a clustered index behind it. Not ideal, which is why we don't generally create it that way. It doesn't name it nicely either in the background. It gives it a SQL generated name, but it also defaults to clustered. At least this way you've got control over the name, and you've got control over whether it's clustered or not, because you could say non-clustered. So we now put a primary key clustered on. Great. So, okay, what I'm going to do is I'm going to throw dcc drop clean buffers, can't spell. I'm going to throw all of the data out of memory. So basically every time we run this, we're going to be pulling data from disk just to kind of show the kind of pain involved, really. So I'm going to look for me, Phonebook where last name equals me. Now, this would be one of the most common things you would do with a phone book. I mean, imagine a phone book. You're never going to go, I want person ID 12. I want person ID 7,824. You're going to say, I want the last name that. You skim through to the last name, you start looking for the person. So this is the kind of common way of accessing a phone book. So I'm just going to write this query, run it. And what we're going to see is this, because it's all pulling from disk, it's got no useful indexes because we indexed on the person ID, which we're not using. This is now going to take a while. You can see we've now gone past 12, 13, 14. So it's taking a long time to get this data. scan it and look for a name that doesn't even exist. Okay, so it actually took 19 seconds to do that. And if we look in here, it had to read 64,000, well nearly 65,000 data pages off disk. That's painful. Okay, now this is kind of my thing where you talk to a vendor and they say, oh, it doesn't really matter with our access patterns. Well, I'm sorry, but it does, because any search you do that is not on person ID in this case will categorically scan that table top to bottom. You're going to read 65,000 objects off disk. You've got to store those 65,000 data pages in memory. You've got to process them all using CPU. This is painful. It takes time. It's nearly 20 seconds just to establish there's nothing there. So the argument then comes in, well, why don't we just stick a non-clustered index on it? Okay, fine, we can stick a non-clustered index on it. So I can do a non-clustered index, NCIX, I'm just going to call it Phonebook. On Phonebook, you would obviously have a better naming convention. This is just because I'm doing this as a demo. So I can create that, a nice single column. Okay, single column index, so it's going to be thin. It is a copy of that column from the table held on disk, so it takes up more disk space, but you know, we can kind of accept that trade-off. It's just one column, so we've got the whole table, which is our clustered index, and we've got one column. Not too bad. So if I wanted to run this again, I'm going to do a drop, and I'm going to run this. Now what we'll find is, okay, now that's pretty fast. Okay, now that's good. Okay, didn't really do any reads. The world is happy. Okay, looking okay. So we're kind of on the whole thing of doesn't really matter what your clustered is because we've thrown another index on and it's done the job. So what I'm going to do now is I'm going to actually switch it for a name that I know does exist. So I'm going to drop all the buffers again, and I'm now going to search for this. Now you can see it takes a few seconds to return. There we go. It took 4 seconds to return. It's only 600 rows, so that's not the issue of actually streaming it to the management studio. That's SQL taking time to find it. So that took 4 seconds, and if you can see, that was 4,000 reads on disk. Okay, that seems a lot. Now, in the background, which I'm not going to go into for the sake of a YouTube post, but it's all down to key lookups and other such things that we're not going to go into. We're not going to look at execution plans. This is just a very basic overview of primary key as a clustered index. So the thin index wasn't actually very useful. Our logical reads are still around 4,000. If we wanted to make this non-clustered a bit more useful, and we're returning everything, because chances are if you look in a phone book, you want everything back. You want their first name, their title, their address, their phone number, I mean specifically the phone number. You're going to be looking for other columns. So in order to make this non-clustered index efficient, we would have to start adding more and more columns into it. That makes it wider and wider, and we're trying to avoid that. Okay, so we've got our one table, our one single column index. If we start widening that, we're effectively duplicating the amount of data that we're holding on disk. Not what we want. Okay, so is there a different approach? Well, what we can do is, and I've already got this bit written down, so I don't have to type it out manually. So what we can do is we can drop our index, and we can drop our primary key, and that shouldn't hopefully take too long to do. There we go. And now what we're going to do is we're going to create a new clustered index and a new primary key. Now this time the clustered index is going to be on last name, because all of our queries, if we're looking at a phone book, are going to be driven by last name. The main access point into a telephone directory is the last name of a person. Okay, so our clustered index is going to become the last name. Then what we're going to do is we're going to put our primary key back, because we need a primary key. You know, it's part of our referential integrity. It's a constraint, so we need that on there. But we're going to declare it this time as a non-clustered, not the clustered index, just a non-clustered. So if you actually look at this, what we've got is our entire table and a single column index. So we're now in exactly the same state we were at before, with an entire table and a single column. So we're taking up no more space on disk. All we've done is change the access routes into our table by having a different clustered and a different non-clustered primary key. So now let's run our query. So again, we're going to throw everything out of memory. Worst case scenario, we're pulling everything from disk. So now we want to get this. Last time, what was it, 4 seconds? And it did 4,000 reads. So this time, less than a second, and it only did 177 reads. So hopefully this will give you the impression that it does make a difference with your architecture when you're actually putting in a primary key and your clustered index. Don't just say primary key clustered, it doesn't matter. And like I said, the vendor's response of doesn't make any difference the way we access SQL. Users won't notice the performance difference. Pretty sure they would notice what started out as 20 seconds to being less than a second. Even with the additional indexes we added, we only got it down to 4 seconds, and now we've got it to less than a second. People notice that, especially in websites. Applications, I mean websites, usually that's just unacceptable. It has to be kind of 200 milliseconds at most. Even apps, you're going to notice 4-second delay on anything. So it does make a difference. And generally, as I said, the rule of thumb is your main access route into a table is your clustered key. The primary key is independent. If they happen to be the same, that's fine. If they're different, treat them as different. By default, don't just make a primary key your clustered index. Now, I did say at the beginning that I would have a bit of a caveat on this, which is that if your primary key is your access route into the table, it is your main access route into the table, then yeah, by all means, clustered index is fine. There is no kind of categorically it should be this or this. It is done by you knowing how your database is accessed, the access patterns, the architecture required to support the queries. So if you have a table that is only updated by a process that uses the primary key as its driver for the update, and you're doing 10,000 updates a minute every minute, but you might only do 10 reads a minute, then by all means your primary key is your clustered index, because that access route is what you need to be using for those 10,000 updates. The 10 reads could be supported by a different index, or they may not even need an index. They may be allowed to be slow because there's so few of them. But the main access point into the table is what you should be using for your clustered index. The default answer of primary key should be clustered or your identity should be clustered just needs to be gone. And that's basically, that was the point of this little video, was just to kind of emphasize that database design matters. Your clustered key choice matters. Your choice of primary key, the index type, indexes in general, they all matter. An answer of it doesn't really make a difference, users won't notice, is 99.99% of the time categorically wrong. You should always tailor your database to the access patterns in order to get best performance out of it. So hopefully that has cleared all of that up, and hopefully that wasn't too ranty. Hopefully I didn't upset anyone too much. Feel free to add anything you like in the comments. I will read them, I will respond to them, because this is one of my favourite topics. But yeah, for anything else, for anything less opinionated, there is our website, so qtech.co.uk. We've got hundreds of blogs on there, covers absolutely everything. We've also got PowerShell stuff, we've got a little bit of Python stuff, we're going to put some Power BI up, we've got a bit of Docker, everything you could want. So yeah, like, subscribe, comment, anything you like, and I will see you next time.